This lesson about downloading a step file from a vendor, importing it into ONSHAPE, adjusting it slightly, and then sending it to a 3D printer so you can have printed gears while you're waiting on the others you've ordered to come in. Pretty simple process, uses all free software, nothing to buy. This is the gear we're doing tonight. It looks pretty much like that, 24 teeth, 3/8 inch hex shaft, nothing fancy at all. Full disclosure, I found one similar to this done by Bison Robotics on his channel using different software for their CAD system, but it comes up the same way we want. So the first thing, let's go find a gear. To find a gear, we'll go to a place called AndyMark. AndyMark has huge amount of stuff. Tonight we're under hardware, under motion, under gears. And while he has a bunch of them, we're just going to take a standard 20 gear. 3/8 hex steel, 24 pitch, that's good enough. No weight reduction. And see what we can do with it. If you look down here, here's all the different gears. And under 24s, you can have either a 3/8 or a 1/2 inch shaft. 3/8 inch shaft would be a AM 3458, which if we do a find on, we'll find not only the PDF for it, but coming down a little farther, we have CAD files with a step file. Step files being transient files between CAD projects. So once we have downloaded it, we can go over and start up ONSHAPE in a empty file. There's the one I did earlier. We'll do it again. Send that to trash. Create a new document, call it gear. Again, whatever. We are on the hamburger menu, we're in workspace in inches. Plus down here, import. The downloaded step file came in on downloads and it looks like this. It comes up, import this document, import appearances, select import. And it will come up here and it will say importing, importing, importing. And if you'll watch down here, it's doing stuff while it's in here. It says import complete successful, which is what we're looking for. So we'll come over here to the part and there is our gear. Using the P as in Paul key to get rid of all the planes, we now have a perfectly good gear to print. The only problem is this washer face right here. If you put it down on a print platter, we'll try to create support all over this face you're going to clean up for the next hour. The simple way to do this is simply split the part along this face and peel off that washer. In OnShape, you can go up here to one of the features called split, and it says what part. I want to split that part. What do you want to split it by? I want to split it by that face. Watch right over here in the bottom left corner. When I click the green arrow, you'll see I suddenly have two parts over here, which I have this part. If you turn that off, you'll see I have that part and I have this part. So I literally have two parts now. So I'm going to hide that and we will just have the gear with one washer face. The other thing we need to do when you print with a 3D printer, everything comes out a little closer than you think. So this 3/8 hole which if we come down to the tape measure and select it and select one face and select the opposite face, is at 375 spacing. When we print it, it will be several thousandths under that and won't fit the shaft. So what we need is to make a slightly larger hole. Okay, from our gear, what we want to do is to start a sketch on that surface. In for normal, zoom in. We're going to select inscribed polygon, take the center point, pull out, click, set this on 6, click again, and we have everything except the size. If we come up here to the constraints and select the parallel constraint and select that edge and this edge, they will be in alignment. Now what we need to do is we need to adjust this spacing. We'll do that with dimension, select this line, select this line, go in 0.003 thousandths. Little bitty green check mark, and we have a little bitty section in here you're going to have to zoom way in to get. Click on it, and then you can pull back out, go to extrude, remove, check mark. That has made this, if we go back to the tape measure and select that side and that side, our 375 is now 381, because we're going to gain about 3 thousandths on each face when we print. Well, we gain them on my printer. Your printer may be different. You'll just have to print a part or two, figure out what your adjustment factor is for your printer or your setup, and write it down somewhere, and then you'll have the number. But every printer is slightly different. Everything's just slightly skewed, but once you get it figured out, it's all good. Anyway, all we need to do now, we have the print. We simply right-click over here, select Export. We're going to export this file as an STL. There's a whole list of different kinds you can do, but we're going to do STL in binary and millimeters to the download file and hit Export, and it's going to generate an export file. Now I will bring up the slicer, and the one I use is a CURA, C-U-R-A, incredible slicer, and it's free. Keyword here, free. We will select to import this, and in it comes. Unfortunately, it's kind of tilted in the wrong spot, so I'll select that, select this face to the build plate, and select right here on it, and it will lay down flat. And that is ready to go to the slicer. If I select slice, it will come up and save it to disk, or we can do a preview if you want to see what it's going to do. And we can go one layer at a time as we watch it build. And from there, it's actually ready to print. That's it. That's all there is to taking a step file and bringing it into your printer. Talk to y'all later.